only thing that's going to affect it is whether you sleep or gas.
Yep, exactly.
Let's make her proud, you guys.
Then like for whatever number you're looking for X. All of them.
Okay, all of them. Because it's a standard student.
Yeah, you're not going to have a delta H.
We need to be careful with our units here.
Like if you get it wrong with just that, then that's...
Students will be introduced to material online before the class in the form of videos, readings, this sort of thing. In the class itself, they can expect to be doing. That's the big difference. The students are doing rather than listening. So what that doing is depends a lot on the instructor and on the specific class. In my class, that can be writing questions and answering, and then trading with another group and answering each other's questions. That can be drawing a concept map for the chapter. That can be working through drawing schematics of stuff, or that can be working through problems where they're applying numbers. So that's my engineering classes. But that doing in other classes, that might be presentations, that might be debates. It's just using that material and engaging with it rather than just passively listening to it. And what happens to all of these? This one cancels out. So once you get to this result, you have kilojoule per kilomole. In this case, when I teach a flipped class as opposed to when I used to teach lecture style classes, I find that I'm able to assess on the fly whether students are understanding something or not. Whereas in a lecture, I would ask, does that make sense? And you just get no response, or you might get some heads nodding, so you don't really know. Did you get it? Cool, good news, it works. From an instructor's perspective, the flipped class is really advantageous because it allows me to assess and adjust on the fly. In terms of the student outcomes, the student performance in my class did improve when I switched it to flipped class. And every successive semester, as I keep iterating that, it continues to improve.
I said, well, most of this is nitrogen. If I drew a line from there to there,
We'll have a good little mid-range.
and then see where it crosses. And I solved it and I found out how much error there was in that.
It helps you learn to learn from other people rather than relying on just the professor. So like in a traditional lecture, you're sitting there and he's going through a lot of stuff, she's going through a lot of stuff, and you ask a question and it's like, okay, sure, but how does that help me? But now if I ask a question, it's like, this is how it's gonna help you, this is other situations of how it's gonna help you, and you can see it straight away like on your paper while you're working on it. So it's really direct, it's really focused on what you're doing.
Your K value is usually a function of X, so it's like kind of cool.
I don't think so.
It's really nice to work in a team because, like, for instance, if I'm better at one thing, but I don't know how to do this part of the problem, somebody else is good at that part. So we collaborate and it's like, oh, that's how you think about it, that's how I think about it, let's figure it out together.
H2O as a gas.
Yeah. Standard conditions.
Always.
This is the first time that I've taken a class like this. It was not something I expected. Doing example problems in class and discussing all the concepts really helps enforce my understanding, and it motivates me more because I actually understand what's going on and what's being discussed, and the professor actually cares about you knowing the material instead of just preparing for the next test.
Yeah, but I don't know which H values to plug in because I looked at the chart and it just said H, not F.
F plus the delta H,
Yeah.
and the delta H is...
This kind of classroom really puts your ability to learn the material in your hands. Because in a regular classroom, you can go to lecture, you can be on time, you can be early every day, and you can still not understand anything. Meanwhile, somebody else can be not even going, not have to study, and they just get it like that. But this time around, it's what you put into it, you really do get out.
So if you set up the equation... How did you get 455?
We're not only advocating the flipped class approach for our microcampus classes, but we're also undergoing a sustained and focused effort to switch classrooms and faculty teaching methods here on campus. So we want to use flipped classes not because it helps us do stuff internationally, but because it genuinely, we believe it to be the best way to teach students.
So the only time you can't slow down is if the reactants and the products are at the same temperature.
That was actually leading into another question where
I'm getting better at teaching and they're learning better as well.